The future of lathe machines, redefining precision and efficiency. Welcome, engineers. Today, we embark on a fascinating journey to uncover how lathe machines, the backbone of machining operations, are evolving. These machines have been vital tools in shaping the world of manufacturing, and their ongoing transformation is set to redefine efficiency, precision, and sustainability. Whether you're a seasoned engineer or a curious learner, this training will open your eyes to the remarkable future of lathe machines and inspire you to lead the next wave of innovation. Let's dive in and explore how technology, automation, and sustainability are changing what these iconic machines can do. To understand where lathe machines are headed, we first need to look back at where they came from. For centuries, lathes have been used to shape, cut, and turn materials, forming the cornerstone of countless industries. Traditional lathes were manually operated, requiring exceptional skill and precision from machinists. They played a pivotal role in industries like automotive, woodworking, and metalworking. However, as demand for higher accuracy and faster production grew, the manual lathe began to show its limitations. Enter computer numerical control, CNC, technology. This game-changing enhancement automated many manual processes, allowing for unprecedented speed and precision. Engineers no longer had to rely solely on hands-on machining. Instead, they could program their lathes to execute complex tasks with breathtaking accuracy. The shift to CNC marked the beginning of a new era in manufacturing, and today, we're poised for the next technological leap. Modern CNC lathe machines have taken precision manufacturing to a whole new level. Equipped with advanced software and digital controls, they're capable of crafting the most intricate designs without breaking a sweat. Whether it's creating finely detailed threads, shaping materials into complex geometries, or achieving surface finishes to exacting standards, these systems prove their value every day. Aside from accuracy, these machines also significantly reduce material waste, a major concern in high production environments. CNC programming allows for optimal tool paths, ensuring materials are used efficiently, saving costs and promoting sustainable practices. Manufacturers now benefit from shorter production timelines, as well. Setup times that used to take hours have been reduced to mere minutes. Digital simulation tools allow engineers to test their designs virtually, minimizing trial and error. These are just a few of the innovations that are shaping the capabilities of today's advanced lathe machines. But this is only the beginning. What tools like CNC started, disruptive technologies like artificial intelligence, AI, and machine learning are about to supercharge. Imagine a world where lathe machines don't just follow programmed instructions but actively learn and improve from each operation. This future is fast approaching. AI is empowering lathes to self-monitor and adapt autonomously, unlocking game-changing capabilities. For instance, with predictive maintenance powered by AI, a lathe machine can detect signs of wear and tear in cutting tools or mechanical components. Instead of waiting for a failure to occur, the system alerts engineers to take corrective action proactively. This prevents costly downtime and ensures uninterrupted production. Additionally, machine learning is enabling lathes to fine-tune manufacturing processes. By learning from data collected during thousands of machining cycles, the system can optimize parameters like feed rates and speeds automatically. Think of it as a smart assistant working quietly in the background, ensuring your machine is always producing its best. This type of technological synergy not only boosts efficiency but also enhances job satisfaction for engineers. With the repetitive tasks handled, you get to focus on creative problem solving and innovation. Now let's talk automation, a hot topic reshaping manufacturing landscapes worldwide. Automation, when integrated with lathe machines, is revolutionizing production efficiency. Modern production floors increasingly feature robotic arms working seamlessly alongside CNC systems. These robotic arms load raw materials onto the lathe and remove finished parts, enabling lights-out manufacturing. This means production can continue around the clock, even with minimal human supervision. What does this mean for engineers? It's an opportunity to shift focus from operating machines to managing workflows. With automation, you can oversee entire assemblies instead of individual tasks, allowing you to scale your impact across larger systems. Moreover, this 24/7 operational model is essential for meeting tight deadlines, handling high demand periods, and maintaining a competitive edge in fast-paced markets. Automation doesn't just extend production, it transforms it. As industries push the boundaries of innovation, new materials such as titanium, carbon fiber composites, and superalloys are entering the spotlight. These materials are durable and lightweight, making them critical for sectors like aerospace and automotive, but they also pose unique machining challenges. Historically, machining complex materials with high hardness or thermal resistance has been difficult. However, future lathe machines are stepping up to the challenge. Advanced tooling and high-precision spindle designs equipped with modern cooling systems now handle materials like titanium effortlessly. Additionally, hybrid machines combining traditional subtractive machining and additive manufacturing, 3D printing, are gaining traction. These systems allow engineers to create rough components via additive methods and finish them with high-precision turning, a versatile and efficient approach. These advancements promise to unlock new possibilities for industries working with challenging materials. Engineers must stay ahead by familiarizing themselves with cutting-edge tools and techniques to maximize machine potential. As we embrace futuristic capabilities, let's not overlook sustainability, an increasingly important factor in today's manufacturing world. Engineers everywhere are tasked with improving the ecological footprint of their operations, and lathe machines are no exception. Future lathe designs prioritize energy efficiency, reducing power consumption without compromising performance. For example, modern CNC systems use energy-saving motors and standby modes to lower electricity usage during idle periods. In addition, recycling capabilities are enhancing sustainability efforts. Consider metal scrap recycling systems built directly into lathe operations. Instead of discarding waste, these systems feed material back into production, both reducing environmental impact and lowering costs for manufacturers. By combating waste and embracing energy-efficient practices, engineers ensure their facilities remain both competitive and environmentally responsible. The transition to sustainable manufacturing isn't just good for the planet, it's vital for long-term business success. To see how far lathe technology has come, let's look at some real-world applications. From automotive parts like crankshafts and gearboxes to aerospace components requiring microscopic precision, modern lathe machines are indispensable. Automotive manufacturers embrace CNC-powered precision for mass production, relying on repeatable accuracy to produce identical parts on a large scale. Meanwhile, the aerospace industry benefits from AI-driven analytics built into lathes to machine lightweight yet strong parts perfectly suited for flight. One fascinating use case involves medical devices. Surgeries demand non-reactive materials like titanium for implants, materials which advanced lathes can now craft with surgical precision. Consider the life-changing impact of precision machining in delivering safe and reliable medical equipment. These practical successes highlight what's possible when engineers leverage cutting-edge lathe technologies. So, where do we go from here? What will lathe machines look like in the next 10, 20, or even 50 years? The future points toward fully autonomous systems capable of learning, adapting, and executing without manual intervention. Engineers may soon interact with machines via augmented reality, AR, interfaces, programming and monitoring in 3D visual environments. Further integration with IoT, Internet of Things, will create lathe systems that communicate seamlessly with other manufacturing processes, paving the way for smart factories driven by interconnected automation. Customization will also flourish as future machines adapt to personalized designs at scale, meeting unique demands while retaining efficiency. But here's the key takeaway: engineers like you will drive this transformation. Your ability to adopt these innovations and integrate them creatively into workflows will determine the industry's path forward. As we wrap up, let's recap the essentials. Lathe machines have evolved from manual systems into precise, AI-driven, and automated tools. Technologies like machine learning, IoT sensors, and hybrid 3D printing enhance productivity and versatility. Automation and sustainability are not just trends, they are essential for modern machining. Engineers need to embrace advanced practices, learn about new materials, and prioritize green manufacturing to lead the future. The future of lathe machines is bright, and it's calling for engineers who are ready to innovate, adapt, and thrive. By equipping yourself with this knowledge, you're taking a vital first step toward making a lasting impact in machining and manufacturing. Thanks for joining us on this exploration of the future. Now, it's your turn to shape it.